Hey, what's up everybody? This is SancLogic, and today I wanted to show you how to create an alert in Splunk. I've been practicing lately, so I just wanted to show everybody in the community how to do one. Uh, I have 5 that I've been playing about with, so this is the ones that I created. So we've got the Defender Tamper protection disabled, which I think is quite important because if a threat actor gets in and disables anything in AV, especially if he gets GUI access, if it's RDP access or AnyDesk access, they can just go in, click it, click everything off and do whatever they want. And then we have the file upload via command line tool, potential exfiltration. This one's a little bit messy, but I thought I'd play around with it. I'm trying to sort of trying to do catch anything, curl or wget, that kind of thing, but I'm still working on it, guys. So the other one is the endpoint C2 beaconing pattern detected. So because we simulated the use of a C2 within the CTF, we have a lot of traffic that we can work with and try and create some sort of detection. So that's what I was trying to do. I think it's good as an early access kind of detection where you catch them early on instead of doing detections for later stages in the kill chain. And then another one here is for the Serotal lolbin download, as it can be abused as well. And I abused it quite a bit, actually. I used it to download my tools or simulate the download of tools and abusing that kind of thing. And the other thing is we simulated credential dumping, and we wanted to see what kind of logs Sysmon produces, and then from that we can create detections as well. So that's kind of what I've been playing around with. I am going to be trying to tweak them and re-simulate and see if they trigger, but this is kind of what I was trying to do. So I'm going to show you how to do the tamper protection one and the LSASS one, and just go through the logic and how it shows up on Sysmon. And to be honest, Sysmon is so good at doing these detections. It certainly makes your life easier. So thankfully, Microsoft, I think, is going to be implementing it natively in the next operating system that they're going to release. So that would be pretty cool. So Defender Tamper Protection disabled. What does that do? So basically that catches attackers disabling Windows Defender before deploying malware. In the KCD Dental breach, the attacker disabled this at 02:39 UTC as their first move. And let's build this out and see what we can do. So this is the query. Obviously, this is set on the last 24 hours, so we want to do all time. Just click. So I did an attack, simulated attack on the 25th and then on the 4th. So I did disable tamper protection. So we got some logs there to play with. So the first thing we need to set is the index, and the index for the query to search, which is endpoint for us here. And then we need to mention the log name, which is Microsoft Windows Defender Operational. And then we have the event code, which is 5007. This specific event ID logs when Defender settings change. Not malware detection, not scans, configurations, or modifications. And then we have message, tamper protection, and then it says equal x4. As you can see here, the old value, 0x1, means that it's on. This one, it's been disabled or been, basically we've changed it. So that seems to be the error code every time you do that, when you disable something within the Defender settings. So I thought, why not put it in the search field in the message, because it's there, and then obviously specify the event code, and then we have the table, time, computer, and message, so we know what's going on. We have the time of when it got disabled, the computer name that's involved or endpoint, and why does that matter for us? like I explained before, tamper protection prevents unauthorized changes to defender settings. If an attacker wants to disable retime protection, they need to disable tamper protection first. This alert catches that preparation step. You get early warnings before they actually kill your AV. Just to be sort of clear, to be able to disable tamper protection, you need to have GUI access. So in our case, it was AnyDesk, which has GUI access, or if you have RDP open and they manage to get in, then they have that access as well. So it just makes their lives easier. So it's good to have a detection for it. At least I think so anyway. So since we know that the logic is producing results, we can go to click alert. And then here we can basically add the name. So the name, we could add KDC Endpoint Defender Tamper Protection Disabled. The reason we're using KDC, that's the client, and then obviously the endpoint we need to specify so we know what the alert is for. And then we have the description. This is important as well. Detects when Microsoft Defender tamper protection is disabled, value 0x4, indicating potential attacker evasion. So I'm going to put the name of the there, and then we put description. So you can run it every hour, cron jobs. It really depends. I prefer cron jobs, to be honest. And for me, an alert like this will probably be a good idea to sort of run it every 15 minutes or every 10 minutes or 5 minutes. It's entirely up to you. So this is the cron expression for 15 minutes. There is a website you can search and you can put whatever time you want and then it converts it for you. Or you can use ChatGPT. I'm sure it should be able to do that for you, or any AI that you use. And then number of results greater than 0. Obviously, we only want it to trigger once. Throttle, usually 1 hour. Could be less. I don't know. Let's just make it 15 minutes. Like I said, guys, I'm not really an expert. I'm just playing about with it and just learning how to do it. And then the other thing I was testing out was sending an email. So you can put the email of the SOC, which we have one. This is our SOC here. So this is where our alerts come. It says critical, high importance, and then it's showing the November instance. So I triggered it to see if it works. So just to show you sort of how that is. There is a spreadsheet, is it? I think it's a spreadsheet where you can download it and look at the actual alert, and it just shows you the details there, which is pretty cool. Anyway, let's go back to our Splunk. And after you do that, you just save it out. I took these off because they weren't working for me, so I don't know. I still need to figure out how to make that work properly. I think the link, because there's quite a lot of validation, and it's Cloudflare, so I don't think it works unless it's in an internal SOC. Might be different, I don't know. So that's basically it. And then the second one I sort of wanted to go through was, which I thought was fascinating and something I learned, was the LSASS dump. So the second detection rule, LSASS memory access. This is the critical detection for credential dumping when Mimikatz or any credential theft tool access LSASS memory to steal passwords. This catches it. In the KDC breach, this fired at 4:09 UTC when the attacker dumped credentials. So let's build it out. The logic here is quite complicated, I thought, because I had to put all the different variations of the grant accessed. And then we wanted to search or exclude the typical sort of processes in Windows that use that LSASS for access to run, Windows normally anyway. and then we wanted to sort of produce the details that we wanted. So that we want the computer, we want the source image, target image, and access, and the source user. So the logic looks something like this. And then we do all time. As you can see, it's picked up everything, even my other attacks, which I've simulated. And as you can see here, the grant access is 0x1010. Each one has a particular meaning. Let me have a look at my notes. So we we want to specify LSASS, which we have, the target image. And the top here, and then event code 10, which is the log that can tell us if LSASS has been messed about with. And then we have, these are the memory access permissions. Okay, so let me try and go through them and explain them. So 0x1010 process VM underscore read plus process query limited information. This is the exact permission Mimikatz uses to read LSASS memory. So, and then the 0x1410 adds process query information. Some credential dumping tools use this as well. And then we have 0x1438 and 0x143A. These include additional permissions like process VM operation, more aggressive memory access. Normal programs don't need these permissions to access LSASS. Only credential dumpers tools do that. So, and then this is kind of us whitelisting the normal processes that function with the use of LSASS. So this is our whitelist. These are legitimate Windows processes that do access LSASS for normal operations. So we don't want false positives as much as possible. In the KCD breach, this caught msedge.exe, which was actually Mimikatz renamed accessing LSASS.exe with 0x1010 permissions. So I think it works pretty well. And then again, you can just, I don't want to create a table. Here we go back. And you can save it as an alert as well and do the same process. So that's basically the alert all set up. I do want to sort of show you the ones that I did earlier. Here we are. I'm going to tweak them a little bit. So I don't really want to go through the other ones because I didn't find them really sort of useful. I just wanted to make them and see how they work. I think they need a little bit more work. There is a good one that I did try to get to work properly, which was the beaconing one. So this is the beaconing one. Exactly the same concept. So the whitelisting these, we don't want internal IPs. Initiated equal true event code. So basically we use an event code, the network one for sysmon, and the endpoint, and initiated equal true. We want the successful actual connections. And then we did like a bucket. So 1 hour, we don't want to do it every 15 minutes because it's going to get annoying. There's going to be loads of alerts and it's just, it's not needed. So 1 hour is good. I mean, it could be that we should do it every 30 minutes to catch it quicker, but yeah, there's a lot of things you can play about with here. So I did 50 connections. After 50, it should give us an alert. Since we know beacons, they like to call out every 1 minute or every 5 minutes or whatever. So it's kind of constant. So we don't want, I mean, when we did the simulation, it was like 1,580 something times that it beaconed back to the simulated sort of C2 server that we did. So yeah, we don't want that. So this, but it did detect the other previous attacks that we did. So that's pretty cool. And then obviously we're giving it a name there, and then these are the details that we want to see so we know what's happening. Let's run it. Might not be a good idea doing it all time, I think. Let's pick a range. Date range, not this one. Between 4th, and then we have 5th. Let's do that. And there we go. So it's 1,484 events. So because we did it an hour and over 50, it's given us 8. So I mean, it will give us 8 alerts, better than 100 alerts, I guess, because the count is over 50, so 96 most of these. I mean, maybe you can make it a little bit more, but kind of 50 is like the middle ground, I thought anyway. If you make it less, I think you get more alerts, and we don't want it too much, then we won't catch anything. And then again, same thing, just go to alerts and set it up. So I'm gonna actually show you that particular one. Where is it? There we go. You can see the whole alert, how it's set up there. So we got the name, we got the description, we got the what we're searching for, and I've done it on a cron job here. I think this means every hour. So I did that on purpose because I don't want it to be more. And then here we have the email details saved. That's basically it, really. Save that out. Done. So that's my kind of attempt at doing alerts in Splunk. Hope you enjoyed the video. Leave a comment and give us a like, and hopefully I can do the next video on dashboards. I do also have another video on the actual investigation itself, so hopefully I'm going to be releasing that soon as well. Thanks guys for listening. Bye bye.